Next to me on the bench today is the ASUS Pro WRX80E Sage SE Wi-Fi 2 motherboard. And this promises to be everything a PCIe lane junkie such as myself could ever possibly want in a home lab server. Unfortunately though, it's not quite as straightforward as that, and we'll get into that throughout the video. The platform seems to be plagued with some weird little niggles, little weirdnesses. It's also getting a bit old. I decided to pair this meager amuse-bouche of a motherboard with the Threadripper Pro 5955WX CPU and 512 gigs of DDR4 ECC memory too. This is a glorious powerhouse, a symphony to home labbing. It's got fast single-threaded performance, fantastic multi-threaded workload performance too. So I guess we'll just end the video there, right? Not so fast, because there are a couple of elephants in the room we should discuss. Before we get to them though, namely the price tag and discuss why getting Proxmox to even boot was such a pain in the derriere, let's take a look at the hardware itself, because this combo is pretty special. Released in March 2022, the AMD Ryzen Threadripper Pro 5955WX 16-core 32-thread Zen 3 chip sits at the entry level of AMD's workstation-focused Threadripper Pro 5000 lineup. I do find it funny when a CPU that costs $1,000 is referred to as entry level, but when we remember that the 5000 series of Threadripper Pros goes all the way up to north of $6,000, yeah, I can kind of understand where that comes from. The 5000 series is based around the Zen 3 architecture from AMD, which is built around the 7nm process, spreading 64 megabytes of L3 cache over 2 CCDs. Now that layout becomes important when we start talking about memory performance in just a second, but the base clock of this chip is the fastest available in the Threadripper Pro lineup at 4 GHz base clock, turboing up to 4.5 GHz. Now for those of you looking to run a lot of virtual machines and do just a lot of parallel processing, those fast single clock speeds become important for single-threaded tasks like WireGuard encryption, unzipping and decrypting files, things like just Windows, just like single thread speed to run quickly, even in a virtual machine. So despite the fact that you've only got 16 cores available, they are 4 GHz cores, which should give you quite a lot of headroom when it comes to running all the virtual machines that you could think of. There are 8 DIMM slots here configured in an octa-channel configuration. So ostensibly what that means is you could put 7 sticks of RAM in this, or 5 or 3. Like, you don't have to do pairs of sticks of RAM like you do in consumer grade systems, for example. The downside of the dual CCD layout though, so AMD Ryzen chips have a chiplet layout, so they basically bolt a couple of CPU dies together into what are called smaller chiplets. You have to have some kind of a connecting fabric between those dies, and the scheduler has to pick somewhere to put and allocate the RAM and the processes. So if you've got a bunch of stuff loaded into context on one CCD, and then for some reason the system picks the other CCD to run the task, there's going to be some extra latency involved in that kind of transition from CCD 1 to 2. That generally hurts the maximum available memory bandwidth, as discussed in that Reddit thread linked below. Good news on the PCIe front though, this is a Gen 4 capable system with a full 128 lanes for massive expansion capabilities. You can bifurcate pretty much all the slots individually, although I did see a note in the manual for the motherboard stating that this board, despite the fact that each slot is individually bifurcatable, you can only bifurcate up to 10 SSDs in here. So just, be aware there are some weirdnesses. Even though you've got all the lanes available, depending on your motherboard, you might run into some weirdness and how you can actually take advantage of that. Now you can see here, this is where the 5955WX fits within the 5000 series lineup. At the top, we have the 5995WX, a $6,500 CPU, which has quite a slow base clock, but you more than makes up for that for multi-threaded workloads with the 64 cores and 128 threads available. The trouble with this CPU at this point though, is that the Zen 3 architecture is just getting a bit old. It was released in March 2022, so 3 years ago as of recording. And of course the newer Epics and Threadrippers are now beginning to become available. 7000 is available, and I've read rumors that there will be a 9000 Threadripper coming too, despite some people claiming that Threadripper is end of life. And those bigger chips have distinct advantages if you need them, notably vastly more PCIe lanes than the consumer-grade counterparts. But it's hard to ignore the sheer raw performance of something like the newer Zen 5 chips with the, what is it, the 9950X, for example. This is based around the Zen 5 architecture from AMD, and you can see here in this chart that the sheer performance, the sheer grunt available from that 9950X actually puts this Zen 3 part to shame. Despite the fact it uses less power, despite the fact it's half the price, the new architectures are just faster. Single core performance is better. The 9950X significantly outperforms the Threadripper Pro in single core benchmarks, with a 50% higher score in Geekbench 6. This is largely due to higher clock speeds and also some architectural improvements too. With multi-core, the same story is kind of true too, where despite both CPUs having the same core count, 16 cores and 32 threads, the 9950X leads by about 35 to 66% in multi-core benchmarks across various tests. This advantage is likely due to Zen 5's improved efficiency, higher IPC or instructions per clock, and those faster clock speeds that we talked about. Now we come on to power efficiency, and the story continues to be in the favor of the Ryzen 9 9950X, which has a TDP of just 170 watts compared to the Threadripper Pro's hefty 280 watts. This makes it far more power efficient, which is reflected in its higher performance per watt metrics. Now, this is probably really important for those of you wanting to do this in a home lab scenario, whereas the Threadripper Pro is kind of more aimed at that, splitting that difference between a real server and a desktop, like a gaming rig, really. So that's what the workstation-class boards are really designed for. So the Threadripper Pro is probably best for those users that need massive memory bandwidth, ECC memory support, and huge amounts of PCIe lanes available to connect a metric boatload of PCIe devices to their systems. This makes it ideal for things like rendering farms, virtualization servers, although we'll get onto that in just a minute, and things like scientific rendering and data processing workloads that just need that sheer grunt of many cores and lots of power and lots of things and lots of stuff connected to a box. The 9950X though might be a superior choice for desktop users who prioritize raw CPU performance for things like gaming or generalized workloads, where those higher clock speeds and the power efficiency are more critical than the memory bandwidth or the number of PCIe lanes available. Now let's take a look at the ASUS Pro WS WRX80E Sage SE Wi-Fi 2. And the 2 moniker is important here. This is because the SWRX8 socket that the Threadripper Pro sits in is uncapped. They've made it so you can actually overclock this CPU on this motherboard. The version 1 you couldn't, but the version 2 you can. Now there are 7 PCIe 4.0 16X slots here, Gen 4 slots. The WRX90 board, the next chip up, has Gen 5 slots, but this one, because it's a few years old, they're Gen 4 slots. As discussed, there are 8 RAM slots available in an octa-channel configuration, 8-channel configuration, and the storage options are pretty beefy too. There are 3 M.2 PCIe Gen 4 slots, 8 SATA 3 slots, as well as a pair of U.2 ports, which can be configured in either PCIe mode or NVMe mode, or SATA mode, so you can get SFF breakout cables that will connect each of these slots to 4 hard drives each. Networking's a pretty good story too. There is a pair of Intel X550 NICs on the back using RJ45 connectors. I think I would like to see in boards like this the option of an SFP Plus connection. I mean, there's a pair of NICs back there. Why can't we have one that's RJ45 and one that is SFP Plus? The RJ45 stuff just runs so hot, and then I need another connector on the end to convert that back to RJ45, back to SFP Plus in the switch anyway. It's a minor niggle, but I would just love to see it. There's also Wi-Fi 6E if you need Wi-Fi in a server. Now, the other thing that I haven't mentioned yet is IPMI in here. You can actually connect into one of those Intel NICs and get a full IPMI experience, remote management experience, built directly into the motherboard. It's a pretty good implementation. It's similar, it looks a similar theme to the ASRock rack implementation on some of my other boards. But you can control things like fan speeds, look at sensors, power the system on and off, install an OS, all that kind of stuff No extra licenses are required, no weirdness like iDRAC or anything like that. Now, when it comes to installing this beast of a motherboard into a server, I'd be remiss if I didn't mention that the board is physically huge. It's big in practically every single dimension. Now, it states that it's an E80X board, but in fact it's actually slightly wider than the E80X spec. And that becomes a real issue when you start connecting things down here in the bottom. The PCIe power slots that are down there, so I actually ended up having to use this breakout cable, which is a single 6-pin to a pair of 6-pin PCIe power. This is from my old Bitcoin mining rig. I've saved it for all of these years, and you know, everybody has a box of cables somewhere that they're saving for a rainy day one day. Well, this was mine. This was my win this week. But the trouble is there isn't enough clearance because rather than the connectors being upright like this, they're angled at 90 degrees. So if you picture this in a case, you've got the power supply here and the side wall of the case right here. Certainly in my Rosewell LSV 4500 that I was using, which is a standard 19-inch rack case, and that's a big case. There's only fractionally enough room to squeeze those power connectors in between the side of the case and actually get them into the motherboard. And in fact, I had to lift the board up, put the cables in, and then kind of shove it down a bit to get it to fit. And the same is true of all of the other connectors on the side here too. There's no way you're getting the USB 3, you know, this style header, for example. There's no way you'd bend that if it was on the bottom here. Down there as well, you've got a breakout for a VGA connection. There is no VGA port, or in fact, there's no display out on the back of this motherboard. So if you're not using the IPMI or a graphics card, I think it's a fairly safe bet to assume that most people doing a workstation with this are using a graphics card. But for those of us doing a headless server, just a VGA port would have been nice. I mean, I kind of understand why there is no VGA port, because they're quite big and bulky and old at this point. But also having a separate header sort of here and then dangling a cable underneath my GPUs in what's already a pretty congested area anyway, not the best choice in my opinion. But the other thing to bear in mind when it comes to power is, so not only do you have to connect up this pair of auxiliary 6-pin connectors here, because there are so many PCIe slots that it needs extra power, because each slot can pull about 75 watts, I think, per the ATX spec. So 7 times 75 watts, that's a lot to go through here. So not only do you have two 8-pin connectors for the CPU, the 24-pin motherboard power connector, you've also got an extra 8-pin connector here, because the CPU can pull up to 280 watts. You've then got a pair of 6 pins down here. So by the time I'd hooked up my power supply to these two 8s, this 8, and these two 6s, plus my graphics card, the NVIDIA A4000, I was out of cables. I was out of, it's a brand new, it's the GX1200, it's a brand new power supply, and I was out of cables. So I ended up having to use this Bitcoin mining rig splitter, as I talked about, which takes a single 6 to two 6s, shove that in the bottom, and, it was fine because I'm not completely maxing everything out in this board. But just something else to be aware of, that you're going to have to plan your power supply for this board pretty carefully. Now let's talk about power usage for a moment, and let's just start this section by tempering expectations by saying that despite this CPU being the lowest core count in the Threadripper Pro range and the cheapest, it's a toasty boy. Full load, no PCIe devices, with a stress test, a synthetic CPU load, was very easily able to get this to pull 360 watts from the wall, and idle was 180 watts. So it's a pretty beefy system, and by the time you've added a few PCIe devices, you're looking at a pretty easy system idle of 220 to 250 watts. And then by the time you switch on a Windows VM or something like that in the system, you're going to add another 100 watts to that just to idle. So just plan your cooling accordingly, because this is a toasty, toasty boy. So now we get into the Proxmox booting problems that I had with this motherboard. This caused a few extra grey hairs to appear in my beard. So a long afternoon turned into an evening of hacking when the vanilla Proxmox ISO just would not boot. It would hang after selecting boot at the loading initial RAM disk option. So I ended up supplying a kernel command line argument of PCI equals nomconf after Googling around for God knows how long. And the installer finally booted, so I was able to proceed as usual without incident. However, the system after install still needed PCIe nom-conf to actually even boot. So I then looked at upgrading the BIOS and flashing the BMC, which was done using the inbuilt IPMI, and it was kind of painless, really. But that reset all of my BIOS settings I've been tweaking around with all afternoon too. And so I ended up reaching out to Wendell, who helped me figure out the esoteric combination of BIOS settings that were required. Notably, IOMMU. This was set to auto in the BIOS for me, but I had to actually physically go in and change that to set to be enabled, despite the fact that I think AMD CPUs have IOMMU enabled out of the box by default. I had to actually go and physically change that BIOS setting. There was also another setting of PCIe 10-bit tag support that I had to update too, as well as a few other things, which you can see here in the screenshot too. I'm not sure which one of these settings actually in the end made the difference that allowed me to boot without the PCIe command line flags of nom-conf. But once I had booted, I started noticing AER errors, or advanced error reporting errors, in dmessage. There was a bunch of stuff going through here related to bad TLP and just a bunch of stuff related to storage. And so I used a command called lspci-tv to determine which devices in the PCIe tree were causing these issues. And initially, the A4000 was showing up along with a pair of Toshiba data center grade NVMe SSDs in the onboard slots down here. So at this point, I jammed in my 2 PCIe 6-pin aux power cable, and the A4000 errors went away. So just bear that in mind. If you are seeing PCIe errors, those 2 ports down the bottom don't seem to be optional. However, despite that, the Toshiba SSD related errors remained. Now, some folks suggested setting the PCIe link speed to Gen 3 to try and resolve this issue, but so far as I could tell, there isn't a way to do that for the onboard slots. Now, I could put the Toshiba drives into one of these cards and then bifurcate that, and then set the link speed in the BIOS that way, but when it came to the onboard slots, I couldn't figure out how to do that, or indeed if it's even possible. Now, are these errors harmless? My research tells me maybe. In fact, if you look at the wording of the error message, it says the hardware error has been corrected and no further action is required. So in terms of whether there's an immediate concern or not, I think the corrected errors are fairly common in high-performance systems, at least according to my research anyway, especially those with complex PCIe topologies like the workstation board in front of me. They don't necessarily indicate failing hardware, but what they can sometimes indicate is issues or minor issues with signal integrity or some kind of a firmware bug. And the frequency of these errors was what concerned me. Roughly every 1 to 2 minutes, I was seeing the errors printed out. And in general, the research that I did told me that if these errors were sporadic, they can generally be safely ignored. But I just don't feel comfortable building a new server around such an expensive platform and seeing these errors come out in the dmessage logs every minute or two. You can add PCI equals no AER to your kernel command line arguments, and I believe there used to be a BIOS setting, at least Wendell said so, but there doesn't appear to be one anymore. And that no AER setting will suppress the errors in the logs, but they're still there underneath. So yeah, I just don't feel comfortable with it. I also don't want to downplay the frustration I had with the process of just getting the Proxmox install ISO to even boot. I should say that NixOS booted straight away, no issues. Arch booted straight away, no issues. Same with Ubuntu. But for some reason, Proxmox, despite the fact it's using an Ubuntu kernel, it was just being a diva. So I even tried upgrading my kernel from the default, I think it's 6.8 that Proxmox ships right now, to 6.11. Made no difference, unfortunately. But the long post times, whether it's due to the amount of RAM or just a platform issue of 1, 2, 3 minutes each time, make this a really long, drawn out, frustrating process where you sat there just tapping the delete key or the select boot option key just to try and get into the BIOS. So a big thanks must go out to Wendell for helping me figure out some of the BIOS settings for boot parameters, even if they didn't ultimately end up helping me much with the bad TLP or bad DLLP errors that I was experiencing. And it seems to me that Threadripper Pro is a bit of a picky platform when you look at the general blogosphere or forumosphere of posts that people make about this stuff. There are lots of people having similarly esoteric issues as myself with this board. Maybe I was just spoilt by the experience of building in the EPYC 7402 base system last year, where everything just worked first try. It's so rare, but when it happens, I mean, in that video, I remember being a little like, it just worked, like it was no big deal. But this is a reminder to me of just how rare and how nice that experience was. So despite those negative things, PCIe pass-through on this board was a piece of cake. Getting it actually working was pretty much a non-event. It just worked. The I/O MMU groupings were good, like my graphics card had its own dedicated group. In fact, each slot seemed to have its own group. And overall performance was fantastic. You know, I've grown fairly used to the speed of my servers over the last year or two, and this thing is a notable step up. So I can only imagine what it's going to feel like if I built a server around the 9950X, for example, that we talked about earlier. So what are the conclusions then? Well, I think it's clear to me that this board has, as my school teachers would have said, it has a potential if only he'd apply himself. There are dozens of posts with this motherboard and the previous version trying ever more random fixes to try and resolve the AER errors. And let's not forget that this is still an expensive platform to buy into. $2,000 for just the CPU and the motherboard, coupled with the fact that it's a 3-year-old platform too. I kind of expected better from a stability point of view. Like I expected the Linux kernel to have picked up all these little weirdnesses. And the errors logged might not be terminal, but they don't give me the warm and fuzzies that I want from a system like this. Maybe the fact I had to spend 3 or 4 hours just to get an OS installed and reliably booting soured me on the entire system. Maybe it was the price, maybe it was the heat that I could feel emanating from the back of the system at all times I was sat next to it. It was a combination of all three. Maybe it was just the fact that I saw AMD release the 9950X 3D this week as well. I think if I could find this platform for a good price, let's say something around the price of building a 9950X based consumer system, it would make a lot more sense. But as it stands, this is a $2,000 platform, and I could build literally two 99, which is a top-end desktop chip. I could build two 9950X based systems for the price of this one. So paying full sticker price for something that feels, I don't want to say half-baked, but just has little niggles and little issues because Threadripper Pro isn't mainstream, so it just doesn't get the same attention that EPYC does in regards to the server platforms and the AM5, the Zen 5 stuff for the 9950X and the desktop side. It just doesn't get the same attention from ASUS, from AMD, as some of the other things in the lineup. It fits in this weird kind of middle ground that nobody's paying much attention to. It's also a bit power hungry, honestly. You know, just that idle power being north of 200 watts for me is a bit too much. And it's a shame because the performance of this chip is actually really pretty good for what I need it for. And all of the PCIe lanes, the bifurcation stuff, all of that just combines to make this really a bittersweet review for this motherboard. I really wanted to like it, but in the end, the newer Zen 5 consumer chips are just so fast and relatively affordable compared with this system. As I say, I could literally build two for the price of one. So with some careful planning, upgrades, and consolidation of devices, I think, for my use case at least, I could probably make a pretty good case for a Zen 5 based desktop chip for my future server, although that might be a future video. So for now, I think my time with the Threadripper Pro platform is about to come to an end. So I might go and brave the thunderstorm that's raging outside and go and return this thing to Charlotte. Thank you so much for watching, and until next time, I've been Alex from KTZ Systems.